Swayam Prabha. Digital India. Educated India.
Hello friends. So, we have come to the almost end of production of vacuum. Today's lecture, which is lecture number 20, we will be concentrating on the selection criteria for choosing a vacuum pump. Well, this is a very important lecture because it is related to the purchase. Whether it is a scholar or a student or a professor or an engineer or a technocrat, finally has to decide. There are so many pumps, varieties of pumps for the same pressure range or a sequence of pumps to be used for getting a particular vacuum or sometimes special requirements like that. But I am telling you, all pumps are equally good. Some pumps are good in some pressure range. Some pumps are good because of some consideration. Some pumps are cheap. Some pumps are comfortable. Some pumps are reliable, rugged, and some pumps are friendly. And some pumps are made available in nearby. So, there are so many issues to be thought before you take a decision what I should purchase. It is not just a rule that this pump is good, then why other pumps are being manufactured? Somebody is manufacturing. So, definitely there is some plus for every pump, there is some limitation for every pump, there are some alternatives, but even if some alternative is there, you may not purchase the pump because of cost, things like that. So, in today's class, before we conclude the production lectures, what is it we need to think before we go into measurement? Just spend some time to decide what to purchase. Though it is not an academic matter, purely academic matter, there is some academics in this selection criteria. It involves commercial issues. If you do not have money, you cannot purchase just because some pump is very good. Okay. So, let us spend some time today on the selection criteria of vacuum pumps. Well, here we will be covering various pumps for different ranges of vacuum, and then list out the considerations that we need to worry or we need to look out before we select a pump for a particular application. If it is a classroom teaching or some small laboratory in a university, any pump is all right, because we want to get that pressure and do something else, and it hardly matters whether you do in 10 minutes or 15 minutes. We are not interested in that. But in industry, if for the same ultimate vacuum, if it comes in half an hour, they save enormous time. Okay? Manpower saving, electrical power saving. So, we have to be very judicious in selecting the pumps at that time. So, some considerations for pump selection we will be doing. But an engineer has to also think. It is not some small worker or some at lower level, they simply purchase something and start using it. An engineer has to design some pumps for certain applications, along with all the associated accessories, and comment what will happen if you use this pump, how much time it will take to come to that level of vacuum, what will be the energy requirements, whether it is acceptable, is it chemically compatible, if there is some environmental problems, even if pump is very good, easily available, low cost, you cannot purchase. Okay. And spares are not easily available or very costly, or it involves complicated what you call assembling knowledge, which normally a user will not have, then you should be very careful. But if you are in a big city where the company is next to you, they can come over a call and they will repair it very fast, and you are also having good technicians who to repair. If necessary, some small spare can be made, some nozzle or something in the lab workshop itself. If you have such facilities, you should go for such pumps. So, these are possible only if the design engineer has got some equations with which he can play around iteratively and finally come to a conclusion and go to the boss and say, sir, you purchase this pump, and even if it is costly, it is cost effective and you will get return on investment by this time and its longevity is high. Then naturally the higher authorities will ask, what are alternatives? You will have to convince that alternatives are good, but they have got these problems. So, for this type of knowledge to a design engineer, I wanted to spend some time in this lecture number 20, because almost all the pumps we have explained so far. So, that time we were talking technically, now we are taking techno commercially. Okay. That will be covered in useful equations for selection of vacuum pump. Finally, we will have some conclusions, so that we will have some tips how to select a pump. Okay. The first thing that we need to worry in selecting a pump is, what is the level of vacuum that I am interested? If I am interested in 100 tar or 200 tar for vacuum distillation of a huge distillation equipment, I do not need to purchase a rotary pump or a diffusion pump or anything. They may also produce that vacuum, rotary pump also can produce, but it will not be convenient, it will not be cost effective. You may have to go for watering pump, maybe less efficient, but 100 tar, but you should not have any oil contamination or some water contamination. Then some pumps are ruled out, even if they are convenient. Then you will have to go for screw pump. And some processes have got lot of particulate problems, particles are coming. In a big metallurgical industry, initial production of some nuclear fuel, from a heap of some nuclear dust which has got some small amount of nuclear fuel, you will have to refine them finally to get a small amount of nuclear fuel. Naturally, in the first beginning of the process, you will have a lot of dust coming out. So, pump which is pumping the air residual gases, them particles may float, particularly in the laminar flow or initial turbulent flow, just in the few seconds of pump switched on. So, we will have to take care of that. So, pump should be rugged enough to handle particulate contamination. The pump, even if it is contaminated, does not matter, you can change the oil very easily. So, then you will have to go for roots piston. And you want to save the power, but you want to get a better vacuum, you do not mind spending little bit more money, then you will have to go for booster. And you will have to go for huge pumping speed initially up to -2 tar, afterwards you employ high vacuum pumps, but their backing pumps need not be huge. So, initially use high quality, high capacity rotary pump or roots blower or screw pump, get fast to -3 tar to save the time, that was the criteria. Once that is done, when either diffusion or turbo or cryo is on, it is only backing pump which is taking only few grams of gas, because at higher vacuum mass flow rates are very small. So, that time this huge pump is unnecessary. So, you may have to take it out with the suitable valves or anything, if you cannot physically move, and employ another pump. That is also a rotary pump, but huge capacity is not required after coming to -3 tar. But you may use only this small pump right from the beginning, but instead of pumping down in 1 hour a space simulation chamber, it will take 20 hours, then time is not allowed. So, you will have to be careful in speed of operation, contamination requirements, particulate or anything constraints, and level of vacuum, and quality of vacuum, it should be oil free. Depending on that, we will have to choose. Of course, a very important concept is pumping speed of the pump should be very high sometimes. Sometimes pumping speed need not be high, ultimate vacuum should be very high. There is a proverb, slow and steady wins the race, but not always. You need to do very fast. A silicon wafer is kept in the initial preparation chamber for initial cleaning, etc., before it goes to the next chamber where growth and of the films or various VLSI technologies, and then metallization, all those things are high vacuum. But initially, a quick opened door, you put it into preparation chamber and you have to immediately pump it from atmosphere to fairly good vacuum and do some cleaning operations. This should be done batch after batch in a semiconductor industry, which is coming up in a big way. That time, that speed should be very high. But later, the main process, pumping speed need not be very high. Instead of 1 hour, let it take 2 hours, 3 hours. Quality of the vacuum pump should be very high. Because amount of loads that we are talking in a clean semiconductor industry at -6 star is not much. Small amount of gas for plasma making, it is not much. Quality is important. I want -7 tar, if necessary 10 power -8 tar. With some ultra pure gases going into the chambers for plasma etching, etc., you may have to bring it to -5 tar. But that is a pure vacuum, 10 power -5. It may be better than a 10 power -7 tar of a contaminated vacuum. So, a turbomolecular pump with magnetic bearings or a cryo pump has to be used. Okay? So, these things are very important, but in any case, we have to start from what range we are talking. If it is a low vacuum, 1000 to 1 millibar, these are the options: water ring pump, steam jet, water jet ejectors, diaphragm pump, etc. From medium to little bit good vacuum of 10 power -3 tar, that is also good vacuum, but not high vacuum, a medium vacuum from 1 millibar to 10 power -3 millibar. Low vacuum means, sorry, low pressure, 1000 to 1 millibar, when I said it is a low pressure, then medium, then high vacuum. So, you have to use vacuum and pressure in a laboratory. My students make a lot of mistakes. Sir, pressure is, vacuum is not coming. Vacuum is not coming means pressure is not going down. This also I want you to keep in mind. We will measure pressure, but we call it as vacuum. And I have seen in some companies, they say -10, -20. -20, sir, it is smaller than -10. No, -20 is a good vacuum. Actually, there is no minus there. Of course, I am deviating from the concept, but right now here I am telling, because while you are doing pump selection, you have to keep other things in mind: measurement, materials, system design, what is going to be budget, so many things you have to keep in mind. That is why I am talking all these things. So, low vacuum 1000 to 1 millibar, medium vacuum 1 millibar to 10 power -3 tar, that is rotary vane pump, rotary piston pump, roots blower, screw pump, scroll pump, claw pump, absorption pump. You have so many pumps. You are taken for granted. What to do? Each manufacturer will say, sir, purchase our rotary pump, it is a beautiful pump, it will produce this much pumping speed, this will go to -3 tar. Don't get swayed away by their words. Maybe they are correct, and they will say we are having 1000 meter cube per hour. Immediately you should ask, what pressure? Sir, our things will go up to 10 power -3 tar. Then you ask, what is at 10 power -3 tar, what is the pumping speed? And if you by chance chase that 1000 meter cube per hour, you should not purchase from there. That it is ultimate vacuum means pumping speed is 0. So, naturally manufacturers will tell the maximum possible pumping speed. So, you will have to, as an engineer, as a person who is going to purchase the pump, who is going to select the pump, because this particular lecture is for selection criteria. So, I am thinking from customer point of view. Okay. Of course, I am also aware that company people are quite knowledgeable. They will also explain these things. Sir, if you want this much vacuum with this much pumping speed, you should purchase 2-stage pump. Don't purchase 2 small pumps. Like that, they have got lot of knowledge. In fact, most of the company engineers have got lot of knowledge. So, as a purchaser, if you make a wrong purchase, it is huge money involvement, you should be careful. Okay. If it is high vacuum, all the more you should be careful. 10 power minus 3 to 10 power minus 6 millibar. There are varieties of pumps, diffusion pumps, turbomolecular pumps, ion pumps, cryo pumps. Very costly. If you go to ultra high vacuum, 10 power minus 6 to minus 9 millibar, turbomolecular pumps, cryo pumps, ion pumps, and the cost goes up like anything as you come down. A huge rotary pump, say taking some 10 kilowatt of power, is only maybe a good quality pump, maybe 1 lakh rupee. But a small cryo pump working at 10 power minus 10 torr, taking only some 200 watt power or so, or maybe half a kilowatt or something, but its cost may go up to 25 to 30 lakhs because of technology involved in it. So, one of the criteria is at that working vacuum what my budget can handle. So, you have to see from your budget point of view, and sometimes it is inevitable that you have to purchase a costly pump. Why? Because contamination is not allowed in a semiconductor industry when they are doping parts per million, etc., to make p-type, n-type, and based on which entire chip reliability matters. So, contaminations are not allowed. Residual gas analysis will immediately reject. At this level you cannot grow the films. Okay? You have to be careful. So, depending on the range of vacuum, you have to select the pump. Depending on the pumping speed requirements, you have to select the pump. Depending on the contamination requirements, you have to select. I am repeating because this is very important. So far, it is only technical knowledge. Now, you are going to purchase. Immediately, if you make a wrong decision, you will be in trouble. For example, if it is 10 torr, instead of purchasing a double stage pump, you purchase 2 single stage pumps. You will get more pumping speed if they connect it in parallel. Why should you make 2 stage vacuum pump? You do not require minus 2 torr. And you want a huge pumping speed at minus 1 torr, minus 2 torr, but rotary pump is unable to give minus 2 torr huge pumping speed. You boost it. You may have to spend little bit more money, that will be returned back over a period of 1 month, because minus 3 torr huge pumping speed means pump down time will be faster, processing time will be faster, you will save a lot of money anyway. And the additional power for the roots blower is very small. Okay. So, we will see later in examples how whether you will purchase only rotary pump or rotary cum roots pump. Both may be operating at same pressure. Then third requirement is electrical power. So, coming back to this slide, first you have to decide what range of pressure I am talking and what are available variety of pumps, out of which I will be purchasing one of them. First budget, then contamination problems, pumping speed issues and materials, and weight is also a penalty, and whether it is to be connected with a long pipe, etc., that is to be connected. It is not only pump, you have to be careful. Okay? We will see those things. And nowadays it has become very important in several chemical and pharmaceutical industries to purchase dry pumps. Sometimes people get confused what is dryness. Dryness sometimes in some laboratories they will say dry weather, wet weather, we will think water. But in pumps, dry pumps means oil free pumps. There is no oil contamination. That is very important because hydrocarbon contamination is going to be extremely dangerous for surface analytical equipment, for semiconductor manufacturing, and for food processing. They do not allow oil contamination. This hydrocarbon contamination is not allowed. So, the dry pumps have become very popular, like screw vacuum pump, scroll pump, dry membrane pump, and roots blower, for example, boosting all these pumps. Similarly, turbomolecular pump with magnetic bearings, cryo pump perfectly dry like that. Whereas diffusion pump is not dry, oil contamination will be there, rotary pump, rotary piston, all these pumps will have some contaminations problem. But sometimes they are better than the other pumps where contamination is not a big issue, the quantity of vacuum is important and cost should be less. Rotary pump is ideal. Okay. So, dry pumping without oil contamination is an issue for selection criteria. Second is pumping capacity. Already I told you in the last slide. So, same thing I am going to repeat here. For example, you require a higher pumping speed for the same pressure, you can add a booster. It will boost the pumping speed. That is why it is called booster. Actually, a rotary pump plus a roots blower is together is the pumping station. There is a lot of confusion here. Sometimes they will consider roots blower as the booster. Sometimes they will say together is the booster pump. You get lot of confusion in the market, but that does not matter. It is basically rotary pump or watering pump or steam jet ejector with a roots blower, which we call it as a booster. But you will have to also look parallelly, while putting a additional booster, power requirement should not be very high. So, you will have to take that into account. Already I told you, huge hogging may be required initially, but after some time a good quality vacuum is required, pumping speed need not be high. Then you will have to have varieties of pumps in sequence. And if your ultimate vacuum is ultra high vacuum, right from the beginning history of evacuation, you cannot use oil vacuum pumps. Though you may have very small pumping speeds by dry membrane pump or scroll pump or any other pump. Of course, nowadays screw pumps and claw pumps have come for chemical and other applications. They can also be used in semiconductor industries, etc., because they are also dry. Finally, RGA will tell whether this dryness is acceptable or not, residual gas analyzer. So, engineers should be aware of all these aspects before you select the pump. Simply purchasing pump is not good. Okay. So, if your vacuum is ultimate vacuum is very high, the sequence of all the pumps should be clean vacuum. Okay. So, purchase decision has to be taken based on pump down, cost, maintenance, ease of repair and residual gas analysis. I have not written here, you should also take that. And you can purchase smaller pumps mini and connect all of them in parallel. That is better sometimes. In some nuclear application, they will purchase series along the pipe. Volume is not much. They will distribute the pumps. They are called array of pumps. Because even if one or two down, remaining pumps will be there. All of them together, they are parallelly connected. If you purchase a huge pump of that capacity, single pump, if it is down, process is down. So, redundancy problem has to be checked into that. So, decision has to be taken in a smart manner to reduce the redundancy and selection based on the necessary pumping capacity with the necessary signature of residual gas analysis and with ease of operation and fast pump down, at the end ease of maintenance. Okay. These are additional requirements, pumping capacity and dryness requirements. So, finally, electrical power, because if you spend lot of energy to get a pump, get a small vacuum, that is not a smart solution. You should get the same vacuum with reduced power, because every second instead of 5 kilowatts, if it is only 2 kilowatt power, over a period of 1 year you calculate how many kilowatt hours of energy and that much money is saved. That may be costlier, that may be much more than the pump cost itself. So, there is another criteria which is the most important criteria, that is electrical power chilled water requirement. I have already covered this, I am only going to cover it with the 2 examples. For the same pumping speed, you may have 2 varieties of combinations of pumps. You have to choose that combination which requires less electrical power. You go through the exercise that I have given for a medium vacuum. For example, a 12 HP rotary vane pump, it may pump a 2000 meter cube per hour, meter cube volume to a final vacuum of 10 power minus 2 torr, fine, and it is operating. Similarly, a roots plus rotary combination can also produce same pumping speed at 10 power minus 2 torr, but a small rotary pump and small roots pump together they may have only 7 HP power. but initially you have to spend more money to purchase one roots booster. But the total electrical power requirement for a relatively smaller rotary pump and a smaller roots pump together, total power requirement is smaller than only roots pump, only rotary pump. This happens in process industries. Similar things will be there in high vacuum also, we will see later. These are the typical powers I have given, you go through the example. And if you use booster, you not only get the benefit of higher pumping speed for the same power, you will also get a better vacuum, ultimate vacuum, but all at the expense of higher cost. So, if you say I do not mind spending more time and all, you do not require a booster. You could wait for some time, you have a lot of time to wait, like that. If your production speed is very high, then you cannot. For example, semiconductor industries, high speed production is very important. Market has to be matched to the production. So, for high vacuum pumps, the story is somewhat different. It is not only pumping speeds, there are other issues. A small one sentence I wanted to add here. High vacuum pumps, the compression ratio is million, 10 power minus 8 to minus 3 torr, minus 2 torr, where backing pump is taking care of that. But the mass flow rates are much less because density is very small. Volumetric pumping speeds are high, but mass by pumping speed is small. So, you will have to take care that the motor power requirement is not much, and even that power that we are giving it to high vacuum pump, most of the electrical energy is not used for work of compression. A 1 million compression in a turbomolecular pump, the work of compression is less compared to only some 10 or 100 compression ratio of a typical watering pump or 10 torr pump. It is only 100 compression ratio, but most of the electrical power that you are using like 1 kilowatt motor or so, 60 to 70% is going to work of compression. But in high vacuum pumps, it is not the work of compression, it is consuming energy. It is only the friction and cooling attachments required for that operation or heating requirements, other things. It is not the work of compression. This should be kept in mind. Okay. This is a little theoretical concept, but it will also give an engineer a feel of energy efficiencies, etc. Because when you do energy auditing, you have to take into account. So, that example, for example, for high vacuum pumps, a rotary pump and associated chilled water circulation, all that may cause 3 kilowatt of electrical power to produce 1000 liters per second pumping speed at 10 power minus 6 torr. Fine. A turbomolecular pump may consume only 1.5 kilowatt for the same level of vacuum and much faster speed, very convenient, speed is same for example, but convenience is very good and the residual gas analysis is very pure, clean vacuum. Chemistry wise it is good, physics wise it is identical, pumping speeds are same, but chemistry wise this is better, but cost is high, diffusion pump is very cheap. So, if your metallurgical furnaces even today they can purchase diffusion pumps, because they do not mind, they want minus 6 torr for the sake of minus 6 torr. They are not worried about parts per million type of impurities. Semiconductor industry is a different game. Okay. Even pharmaceutical industry, even their vacuum levels are only 10 torr type or 50 torr, but they cannot allow even small amounts of contamination. Then their requirements are different. Okay. So, a turbo option is better for high vacuum compared to oil contaminated diffusion pump. But if your budget is the main thing, then diffusion pump is better. And even with diffusion pump, if you are having knowledge, you can put some cold trap if you have got a cryogenic facilities nearby, and you may get a residual gas which is better than even turbomolecular pump, because you are adding a cryo pump of inexpensive liquid nitrogen cooled cryo traps, which we have covered in our diffusion pump time. So, if you are having that facility, do not purchase turbo pump, purchase a diffusion pump. Use that liquid nitrogen available. If there is an oxygen plant nearby or a steel plant nearby, you bring some nitrogen and use it as a cold trap. Even with reduction of pumping speed because of introduction of a cryo trap above the diffusion pump, you still have a better quality of vacuum because of cryopumping action, cryocondensation action of water vapor, very good. So, depending on your situation, you will have to decide on that. So, these are the two examples covering various selection criteria I am giving. There are several other things because of limited time. You see, because already my watch, they are telling time up. So, if you are having any doubt, you can always contact me. We will discuss on every small technical issue lot of time. Okay, next slide. This is the problem with teachers. We keep on talking same slide longer time. Yes, okay, but this is online class. So, you have to bear with me for little bit of increased speed. In a typical engineer must consider all these 4 equations before you select a pump. One is the throughput is a product of pumping speed, which is actually effective pumping speed, which I will cover later when I discuss with fluid flow, multiplied by the existing pressure at which you are operating that process. That equation you have to know. So, the pump selection requirement, it is mostly on this S effective. That S effective is available pumping speed at the chamber site, not the pump itself. And if it is inevitable long line is required because of some constraints, this has to be kept far away, then pumping speed heavily comes down, particularly high vacuum zone. You may have 10,000 liters here, but you may have 10 liters per second. But if you are having shorter pipe and wider pipe, you may have 1000 liters. So, with all that, that effective pumping speed into pressure, that means meter cube per hour into that tar, that will be the throughput. What is it is doing? At this pumping speed, it is able to take off all this throughput to maintain this pressure. That is the equation. And that Q is a total of all the other loads. It may be air leakage load, it may be evaporation load from water vapor coming up here and there, or a process load, or a gas load that you are intentionally giving. It can be so many things. If you are maintaining a constant pressure, means it is not a pump down time calculations, it is only a process maintenance pressure. This is the equation. Whereas, as you are allowing pump down, then this is the equation. Time, that means the P is not a equilibrium pressure, it will be a function of time. That time, you have, if the pumping speed is constant, then you can use this equation. If it is variable, then you will have to split it into various intervals and use pumping speeds and take the sigma of all those things and find out the time. And if this is not acceptable, choose such a pump whose S is so high, S effective also is quite high, you will have a less time. So, these two things along with conductance of the pipe, which is inevitable, that has to be worked out. That is also given same unit as pumping speed. We have taken care of all that. We will explain all these equations in the coming sessions. Do not worry. These are the equations. Why I am putting here is, these are additional points an engineer should know while selecting a pump. In fact, most of the 35 years I have experience in 37 courses, most of the participants ask, sir, how do you select the pump? So, if I tell these equations, initially they got confused, but at the end they understood the value of these equations. This is conductance of the pipe, this is the time pump down, and effective pumping speed is coming from 1 by S plus 1 by C. So, manufacturer will give S, the constraints will be limiting conductance, and finally effective pumping speeds, and what are the loads inevitably inside, and whether are maintaining a constant pressure or a pump down, all that selections you will have to do. And if it is a sealed off tubes, you may have to use getter iron pumps, etc., to act like a local pump. Whenever pressure burst is there, it will be able to getter pump. It is not a connected pump, it is a pump located inside the device itself. Similarly, small cryo panels can be there, etc., etc. So, residual gas analysis should also be taken into account while selecting a pump, which I already told you, that deals with the chemistry of the gas, quality of the gas for like semiconductor industries, etc., or pharmaceutical industries. So, certain processes may demand dry vacuum pumps, you will have to take into account. So, all this also is very important while selection criteria. So, I am going to conclude in a minute because time is up. Depending on the required level of vacuum, which is the first criteria, and the process load that is to be handled, that is the second criteria, contamination that is required or its control that is required, you have to plan the purchase of the vacuum pump. But of course, finally budget matters a lot, because when you are purchasing initially, it will have some budget. By the time you decide some other budget is to be carefully monitored. Okay. For the same budget, you can purchase 2 rotary pumps at 20 torr, so that parallelly you can get more pumping speed. You do not have to have 2-stage pump. Okay. And if you do not bother about high pumping speed, you better purchase a 2-stage pump, little slow pumping speed, but you will get a very good vacuum. And if you want to reduce the power requirement, you add a booster and you will get -3 torr and less power. All these things you have to work out. Similarly, diffusion pump or rotary pump or turbo pump, depending on the ranges, whether contamination, whether control or cost, all these things together has to be thought over. So, multiple pumps can be arranged in series or parallel. Sequence of pumps are different. First that pump, then second pump. First that pump, isolate it, second pump. That is called pre-evacuation. Backing pump means first a hogging pump of large capacity, but later a small pump. That is backing options. So, you have to have a thorough knowledge of all these things. But of course, finally, selection of a good vacuum pump is always depends on the person concerned. If he can repair properly, if you can maintain the pump properly, same pump will serve you for 10 years. So, depending on budget, depending on the capability to repair and maintain it, that means the person concerned who is operating, the selection has to be done. So, there are many issues: contamination, pumping capacity, and conductance calculations, and maintenance, cost of it. So many criteria are there. If you can take care of all these things, you will be able to purchase the right selection. With this, the production of vacuum pumps is over. We will go to the next sessions for measurement, system designs, etc. Thank you very much.